Welcome to the Faraday Lab, a key hub for engineering science students at NUS. Today we're joined with Associate Professor Raisul, who will walk us through the opportunities that this lab can offer. So Prof Raisul, can you share a bit more about yourself?
Okay, thank you very much. I'm Raisul. So basically I am involved in teaching different modules under the engineering science program. So I am involved in teaching, say for example, engineering principle in action, similarly for different major design projects as well as the optimization of energy systems. So I'll say that about this Faraday Lab, it is really a multidisciplinary lab where actually students can learn different engineering principles, they can apply their knowledge as well as they can implement different innovative projects. So you see from here you can see quite a number of projects we just put as a sample. So students here can apply their engineering knowledge.
So one of the unique features of the Faraday Lab is its focus on multidisciplinary design. So can you tell us more about how the students apply their theoretical knowledge and learn practical skills?
Okay. The thing is, students are involved in multidisciplinary projects. So for each of the projects, students getting the opportunity to do some mathematical modeling first. Then they come up with the concept design, detailed design. Then for different type of projects, from here you can see that some of the projects here, this is related to different type of sensor development, electronic system, control system like that. Similarly, there is some practical application of their concept here. Few of the other projects is there. Similarly, also student, as I mentioned, that it is a multidisciplinary project. So here also you can see that student can apply their knowledge in engineering mechanics. They do the relevant testing from here. Also, students are doing some of the dryer project. Here actually it is related to some transport phenomena. Transport phenomena meaning it is covering heat transfer, mass transfer, all these things.
So you mentioned some of the sensor projects earlier. Can you tell us a bit more about it?
Yeah, sure. So yeah, students are involved in different sensor projects. So from here you can see that students get the opportunity to use all these electronic systems. So by using these things, students also developing some sensor for the bedridden patients. So here actually students are using developing sensors by using velostat. Here also it is another system where actually students are using some say resistance, variable resistance for developing the sensors, so that once a patient lie down on this one, then the system can monitor that actually where is the stress developed, and they can give this signal to the nurse, so the nurse can take necessary actions accordingly. Similarly here also another two projects. So it is actually the stick, we say it is the smart stick for the blind people. So you understand that in the blind people they are using some stick for monitoring the understanding the road. Here actually it has quite a lot of sensors. This sensor gives signal to the blind guy, so he can understand that whether any obstacle inside or not, in the front or not. Similarly here it got some conductivity sensor, so it can also give signal that whether the road is dry or wet, like that. Here also it is also another sensor for the old people, that if these old people fall down, then actually this system can send a signal to his son, daughter, that whether any accident in the home. So all these things, all the electronic system as well as the control system, everything is actually developed by our engineering science student.
Okay, so these sensor projects are very interesting, but I noticed that there's a very colorful project there. Is that the dryer project?
Yeah. This is a dryer project. So dryer project actually involves transport phenomena. That means it involves some heat transfer, mass transfer part. So after teaching the fundamentals, students do some simple experiment. Say for example, for the case of conduction heat transfer, convection heat transfer, they do the project, they get some hands-on experience. After that they do some mathematical modeling, then they develop this type of dryer. So in the dryer system, they first come up with the concept design, with the detailed design, with all the sensors, then they test the performance of these things. So during doing the testing, they also understand maybe sometimes the performance is not to the extent, so they understand and they learn from their mistake. So finally, after doing all this fine tuning part, then they come up with this type of design. So I'll say that from the mathematical modeling to the design of the system, evaluating the performance of this one, fine tuning, everything actually students take the lead, and they are in the center point of learning the process. We as a facilitator, we just stand beside, and if you understand that there is some conceptual deficiency or difficulties, only that time we step in and we explain the project. That is the way actually in the engineering science students are doing the project. Here maybe quickly another things also, here you can see that one tower project. In the tower project actually it is involved all the mechanical stress, strain. For doing this one, here is actually universal testing machine. This in the testing machine, student first analyze the stress, strain property of different material. Then they develop this one. Then we have the Sekat table. In the Sekat table they install all this one. Then also they test the performance of this one. For doing this one also we have the 3D printer, we have laser cutter, we have actually the Sekat machine, and also beside we have also the engineering workshop. They can use all these facilities to develop all these things here.
Thank you so much, Prof Raisul, for the fantastic tour of the Faraday Lab. It's incredible to see how the engineering science students are able to apply their knowledge in a hands-on and multidisciplinary environment. Thank you for joining us.
Yeah, thank you.